Good evening, everyone. Welcome to this live weekly interactive session. So, this is week number 11. So, we are almost at the end of this weekly live interactive session. So, one more week is remaining, which is week 12, which will be a recap. Uh, uh, it will be a recap of the entire 12, entire 11 week session. Because today we will be going through the road safety module part 2. So actually this is the last module in your traffic engineering NPTEL uh, course, and after this there is no module, but still we have kept one more session, so that if people have any doubts or students have any doubt regarding this entire course, he or she can feel free to ask any questions. And also maybe I will also try to design some questions if possible, or otherwise we can recap the entire traffic engineering course, so that you can remember all the things before you appear for your final examinations. So let's start today. So this module I is about black spot analysis, crash data analysis, as well as road safety audit and safe system approach. Basically, these are the typical outline or broader aspect of this particular week 12 module, or the road safety module. So first let's talk about the black spot analysis. So let's understand that what do you mean by a black spot. So if we say generally, without going into any kind of definition or any kind of standards, so black spot means where frequently accidents are occurring, or where most of the accidents are actually occurred, or the accident prone areas. So where accidents is occurring frequently, which can be called as a black spot. Now the question is, how do you know that what is the number of, like, what do you mean by the frequency? So what is that frequency? What is the threshold? Is there a threshold? So if we say, so in case of India, Ministry of Road Transport and Highways, that is North, they have said that if at a segment of 500 meters, if there are minimum 5 accidents at a time period of 3 years, cumulative, if there are 5 or more accidents are occurring, that can be called as a black spot. Other definition is, if someone found that at any segment of 500 meter length, if someone found out that if your number of fatalities are more than or minimum or greater than or equal to 10, that is also considered at the black spots. So there are two scenarios. So if any one of these scenarios are true, then it can be called as a black spot. So now you can ask that if 5 accidents are occurring, so if, or other definition is 10 fatalities. So accidents may or may not result in fatalities, right? So it may in some cases results in fatalities, or it may not in some other cases. So if suppose there are 5 accidents with no fatalities, right? Suppose no fatalities, but some minor injuries, some major injuries, right? So that is also called a black spot. So in other way, if the accidents are only 2 or 3 and the fatalities are 10, suppose big vehicles collide like buses, trucks, so then that is called a black spot. So now there are different positive and negative aspects are present in this definition of black spot, which is proposed by Morth. So suppose let's say, so black spot means you have the deficiency at that particular spot, means why at a particular spot accidents are occurring. So you have some attribute of that particular location to be considered is as black spot. So your that particular location is causing some troubles, right? But suppose imagine a scenario where a bus, suppose a bus driver does a mistake, suppose he fall asleep during driving and it results in accidents and there are 30 or 20 people died, right? So in that case, that particular spot according to the Morth is a black spot. But is it a black spot? Because the accidents is has occurred due to the driver's characteristics, his attention problem, sleeping problem, tiredness and other things, but not due to the that particular spot or place, we can say. So it is not a black spot. So idea of the black spot is if your location is location characteristics is such that it is creating a road safety issue. So that is the black spot, not the other factors. Because if you remember in the last class, we are discussing that uh, road safety issues can be divided into multifold. So there could be road infrastructural problem, there could be driver's characteristics problem, there could be overspeeding problem, right? So there are many aspects to it. There could be vehicle is itself is not uh, not maybe not what can I say, not adhere to the or not built adhere to the adhering to the safety guidelines. So those things are there. So and I only talked about the definition proposed by Morth, but and there are different countries which actually are using different definitions of black spot. So if you search over the internet the black spot, if you will see that Canada there are separate definition of black spot is there. So different countries have their own guidelines regarding these black spots, and you can see and compare that how our black spot definition is different from them, and is it that we can learn something uh, by seeing other countries definition, right? That you can always do. So now the severity levels. So that's what I said, that suppose the accident has occurred, it may not result in major injuries. It may be resulting in some minor injuries or sometimes major grievous injuries, sometimes even death. So if the death is occurring, then it's called fatal, and other things are not non-fatal, right? Even in the non-fatal, you can say they are serious, major, minor, those kinds of things, right? So so black spot, suppose you are saying that accidents are frequently occurring at a particular location. Suppose we are considering Morth criteria, so 5 accidents are occurring at a particular location, so we can consider it as black spot. So now suppose you have 4 locations, 4 500-meter segments, and you know how many accidents had occurred during the last 3 years, and based on that you have decided the what is the black spot and which location is showing or exhibiting uh, more crash frequency, right? So which is showing or which is exhibiting more crash frequency, you can consider that particular location as the rank 1, right? So it should prioritize those locations first. So it's a black spot number 1 maybe. So now only, so if you have some two locations, at one location maybe the crash frequency is higher, but at other location we are saying this crash frequency is relatively lower, but fatal crash frequency is higher than the other location. So now how do you say that which location to prioritize? So we are saying that okay, both locations are black spot, but but we have to at the end of the day prioritize, right? Because we have resource constraints. So because government cannot uh, means we cannot put every resource to road safety scenario. So we have some limited funds. We have to properly properly utilizing it. So so for the proper utilization of funds, we need to prioritize it. So how do you want to prioritize the black spots? Level 1, level 2, level 3, like that, right? So for crash frequency you are getting some different results, and for from fatal crash frequency method you are getting some different results. So now whom to consider, right? Because sometimes you may think that okay, maybe I will consider only the fatal crashes frequency ones. Maybe you can consider it in some cases, but if you carefully see, so you will see that even if fatal crashes are higher at a particular location, other location major injuries cases are also very higher. So in that case it is very difficult, right? So that weightage is very difficult. So so to to remove or to get rid of this kind of problems, so equivalent property damage only method, which is called the EPDO method in short terms, so it has been proposed, right? So here what we do, we actually considers each. So let me take the pen. So here not only we consider the fatal ones F, but also grievous injuries, major injuries, minor injury, no injury even. So these are different levels, and these are expressed in terms of equivalent property damage, right? So so it's a like a conversion into cost, right? So what is the like for no injury maybe it is very less, this equivalent property damage. For a fatal injury it will be very high, right? So so how do you want to convert it to equivalent property damage? Hmm? So this is a method, because whenever an accident occurred and some people died, not only, so here property means not only the infrastructural point of view there are problems, but also he or she has a family, right, to feed. There also you can consider it as a cost. Also government has to spend some money or in terms of remuneration uh, to the uh, family of that person, right, dead person. And then also uh, that person, if it is working for a company, then also there are some cost issues. So if we can convert it into this equivalent property damage method, so we can actually uh, can give different weights to the different kind of accidents, different weights. So if we are giving different weights to the different kind of accidents or accident fatalities, or in terms of non-fatal also, then actually, and based on the cumulative or based on this weighted score, if we can rank those locations, and then actually we will be doing the slightly better thing than the previous one, when we only consider crash frequency or fatal ones and not considering the non-fatal ones, right? So now there is also a method which is called the upper tail critical test method. So here what we do, suppose we are considering our variable as EPDO for a particular location. So you have calculated EPDO for suppose maybe 500 locations. Here 500 locations means 500 meter or 100 meter segment, small segments, right? Equals homogeneous segments. So now if we can plot these values, and if we assume that it's a Gaussian distribution or normal distribution, that is the Gaussian one, right? So now if we can calculate the 95th percentile values, extreme values, right? Then whichever values are lies outside these ones, we can consider those location as black spots, those two locations, and other locations as okay. So that is the upper tail critical test. So upper tail, because we will not consider the lower tail. We will consider this upper tail because EPDO values high, we want to prioritize those segments. We want to focus on this segments. So these are the different methods to calculate the black spots, right? I hope that it is clear to you. So then let's talk about the crash data analysis. So now you have crash data, right? So how many crashes have occurred in, I know that what is the crashes occurred at different places, different times, right? So now what do you mean by crash rate? So crash rate means number of accidents occurred, suppose per kilometer road. Suppose you have a segment small, you want to calculate that what is the number of accident occurred per kilometer segment, right? Because you have a road network, so per kilometer how many accidents are occurring. Also you can say that how many number of accidents are occurring per million vehicles, right? Suppose your vehicle population is this, that is the vehicles that are traveling along a particular area or particular point, right? Now what is the number of vehicles, what is the number of accidents divided by what is the number of vehicles in million vehicles or whatever it is, that can also be called as the crash rate. Another thing may be because your suppose for a segment kind of scenario, national highways, so your number of vehicles entering and exiting may not actually define your actual thing, because some vehicle may be leaving here, some vehicle may be leaving here, some vehicle may be leaving here, right? See, you saw that okay, number of vehicles entering this, but you don't know that at the end of the day what is the number of vehicles that is, and you have to check each of the locations, right? So now you can do that, what is the number of vehicle kilometer travel, that also you can consider as the crash rate, or you can take into account the crash rate. So now what is the traffic exposure? Here traffic exposure means what is the number of vehicles, right? Because ADT is the generally annual average daily traffic, right? Then you have to multiply it into 365 to get a per yearly, and if suppose we are calculating is for 3 years, so this is the 3 years, so this can you can equivalent to the traffic exposure, and if it is per million, so maybe by 10 to the power 6, right? So it is the traffic exposure. So then the crash involvement rate, so here it is means number of drivers who are committing the crash or who are involved in the crash. So I think it is not in terms of population but in terms of million vehicles. So if you have 50 vehicles, so how many vehicles are causing problem? So 5 by 50 is your crash involvement rate. So then death rate is per 100,000 population, how many people died? That is called the death rate. So these are some of the terms that are frequently used here, and also we will, I think, solve some easy problems related to this crash rate and this traffic exposure and all, so that it will be more clear to you at that time. But these are not difficult things; these are mostly straightforward things, and these are actually given in the PPT as well. Okay, so crash data modeling. Okay, so crash data modeling, now you have crash data, you want to model the crash so that you have a good prediction model, so that you can predict in future that whether uh, at that particular location crash probability is how much, right? So crash prediction means it is actually crash frequency. So based on the previous frequency, now for the time period of suppose next 3 years, so suppose we have 30 years data, or maybe we have 3 years of data, maybe in the next 2 months or next 1 month, what is the crash probability based on the data, right? Any model we can use. We can think, or we can think about the y equal to fx equation. So x is your previous crash data, we want to predict y is also x, but x in future, right? So it's a kind of regression, but we can say that we can equate it to a auto regression model also. Auto regression, because your variable is x and x only in different time periods, right? So that is called a auto regressive model. Auto regressive model. So then, because crash frequencies and crash severities both are two different things. So severe means what is the severity level? Is it that the fatal accidents are more occurring, or major and minor injuries? So that is also a different kind of prediction model in it, right? So it could be a crash prediction model, it could be a crash severity model. So generally crash prediction means it's a continuous variable. Actually, I was thinking that what sort of model actually uh, can be used here. Crash prediction model, crash severity model. Okay. So for severity, we can use any kind of this kind of method where we can give the within a 0 to 1 range, we can get the what is the severity. So these are basically we use in different and urban transportation systems and planning. So we can, if we know, if we can say it's a logit model or probit model, this kind of model. So if you want to know more about this logit and probit, which actually can tell you the probability and the 0 to 1 based on the severity, so actually you can refer to any book on UTSP, urban transportation systems and planning, or take any course about this UTSP, and there actually you will gain knowledge about this probit and logit models. Where in case of prediction, you can use any normal continuous, uh, even sometimes uh, discrete models, 0 1, or like if you say negative binomial, no, poisons also. Poisons can be a, you can use poisons here. It's a count model, so we can use it because it is not a continuous prediction. Crash means we are not dealing with the binary variables, we are only dealing with the discrete variables, but not 0 1, that kind of not discrete, but 1 2 3 4 5 6 7 8. So one of the good model is the poisons, which we generally use to model also the vehicle arrival. If you oh, you already talked about about this traffic engineering only, vehicle arrival poisons model, right? So there, if you remember, for vehicle arrival we are using this poisons model, so we can use this model for the crash prediction models. So the next is how to use different computing method to model the crashes and the crash severity. So nowadays, not only people are using those poisons and probit and logit models, but also the latest trend is used to use the data, because data is used, right? We are getting the data for not only 3 years, because already this kind of crash data has been perfectly, not, I'm not saying perfectly, but at least uh, uh, what was before 10 years before, it is not the same in right now. So present scenario, the situation is better, and people have also used some uniform method to actually entry those data into the database. So now we are getting access to the large database, and actually we can use different machine learning or deep learning algorithms to train our models to get the better and better accuracy. So the basic difference between the normal models, prediction models like poisons and all, so we are assuming that the function is this, right? We know the function, so we are giving x and we are getting y through the function. So in case of machine learning, what happens? The machine is learning that function from the data. We are not saying ki this is the model we should use. We are maybe saying that this is a linear model, this is a non-linear model. Now what type of linear and what type of non-linear, we don't know. But machine, from the data, it will recognize the pattern, it will learn, and then it is giving me the output, right? So these models actually are found to be more accurate in most of the cases, right? So we are using it frequently nowadays. So also the machine learning is the broad domain, that's what I was referring to. And then deep learning method is the, it is also the machine learn, comes under machine learning method, but here actually we deep dive and learn more rigorously, and that's why time complexity of this kind of deep learning models are very high. And AI is the artificial intelligence models which we are preferring nowadays, but still the uh, application context is uh, present, but it has not been that much of utilized right now. So we have scope to use AI in case of different crash uh, more data modeling, right? So and also, if we, I am not going to talk about these models in a detailed way, because this is about road safety. This is not about artificial intelligence and machine learning course. So if you want to take any course regarding machine learning and deep learning, you can search in NPTEL and you will find many courses. and also elsewhere also you can search. So and now let's slightly talk about the supervised and unsupervised. So in case of supervised learning, we have the data as well as the labels, right? So we have x and as well as y. So it's like we know what is the dependent variable and what is the independent variable, right? So now we want to correlate them using the function that will be generated by our machine by learning from the data, that how these are related it will learn. In case of unsupervised, we are not saying anything, we are just giving input and we are saying that you find any pattern. If you find any pattern, you just report it to me. So mostly clustering techniques which used to group different observations, they are falling under the unsupervised learning algorithms. So now suppose you are using any kind of machine learning algorithm, so how do you know that what is the accuracy of that particular algorithm? So obviously if you fed the data, you will receive a result, right? So how do you know what is the error? Is it how much accurate is your model is? So to predict those different performance indices or measures are there. So some of the measures are accuracy, sensitivity, specificity and F measures, right? So generally what we do, we suppose we have some data set, so we are divide the data into training and test. So suppose 70% or 80% we are using to train that data, and then 20% we are using to checking the accuracy. So while we are checking the accuracy, we will maybe one of the measure is the accuracy. So accuracy, what it does what is the true positive. So which are the true positive, that I already know these are the true positive based on the 20% training data levels. Now I know what is the true negative, right? I know these are the true negative, these are the true positive. Suppose it's a 0-1 model, and then I know how many are false positive and how many are false negative. So based on that, I can use this accuracy to measure that what is the accuracy. Similarly, these indices, sensitivity, specificity, and F measure does the similar kind of thing, but using some different logics, right? So you cannot use each of these measures at a one go. Sometimes you may use one measures depending on your context and depending on the problem, and other measures in some different scenarios. Right. So if you have any kind of doubt up to this, you can always ask. So let's continue. So then the next part is the road safety audit. So what we covered that what is the black spot, how do you measure black spot using the data, and then also how do you, if you have the crash data, how to model crashes, right? Crash severity as well as the crash frequency and those things. Now you have data and now you want to do something, either identifying the black spot or the crash data modeling to prediction, right? So these are mainly the reactive measures. So after you got that the data, you are doing something, right? Although crash data prediction may not be falls under the reactive measures, but generally it's a reactive scenario, says reactive case. So in case of road safety audit, what it does is that starting from the, so what do you mean by road safety audit? So road safety audit is a audit that has been done by a road safety expert committee to identify whether there are any deficiencies in the, either in the existing road or in the future any road related project that will be going to be taken up by the government, and also maybe some kind of traffic related any projects, right? So now this road safety audit, it's suppose there is a road, right? So now the team of expert will arrive on that particular road and will try to check whether your everything is happening smoothly or not, right? So other scenario is, suppose government wants to build a road, and and he and suppose the client is uh, someone like NHAI or something, right? So now, because road safety audits road safety, whenever you want to construct a road, it is starting from a feasibility study, and then preliminary design, then detailed design, then construction, and then it ends, right? Open for traffic and then ends. So this is the whole scenario from the feasibility to the construction and opening. So audit also be done from the feasibility studies, then the initial design or the preliminary design, then also the detailed design, and then the during construction, then the pre-opening stage, and also the after the opening stage. So these are the different stages that audit can be done. So if you maintain audit at each stage, so there will be almost no chance, there will not be any deficiencies in terms of road related activity. There will not be any deficiencies, so you may not find black spots immediately, because you have developed the road in such a way by using a road safety audit experts report, so that your road is free from every kind of problems, right? So this is briefly I talked about the road safety audits. So now let's talk about the safe system approach. So this is recently the World Bank and other organization, global bodies, they are actually uh, developed this concept, because road accidents are occurring at a unprecedented rate at different cities, right? Throughout the world, different cities, not only India, and India is almost at the top of road accidents due to the high number of populations that it has. So now they have the this uh, they have proposed this concept of safe system approach. So they are saying that human error will be inevitable, so human are prone to errors, right? But that error may not lead to the fatalities, it should not lead to fatalities. So although human make some errors, so there will always be room for improvement, means there should not, maybe minor injury is acceptable, but death is not acceptable. So they are saying that zero death, almost we should build our road in a manner that there will be zero deaths. Also they are saying that if your collision speed increases, then there are chances that the fatality will occur will also increases, right? So they want to develop a safe speed limit, and they want to they build the road in such a way, so that even if human commit mistakes, there will not be any deaths. So that is a brief overview of what is called by a safe system approach. So then safe system approach has several components. First is the road safety management. Right? So how do you manage the road safety, right? Then also the how do you want to make the safer roads, and also the associated road sites. and then the safe speed. So how do you define the safe speed? So then who are the safe road users? So how do you want to make the road users safe? Because pedestrians and bicyclists and the non-motorized users are mostly the vulnerable road users, right? Then also the safe vehicles. How do you want to make the safe vehicles? Then even if some accident occurs, so how do you, what is the reaction, or how, what is the arrangement to effectively post crash rate care, right? So first is that you have to build road in a safer way. You have to install each devices, so the road safety management plays a big role. And then you have to impose safe speed limits. I have to decide what is the safe speed limit, and then you can go to the uh, your road should not lead to the death of the vulnerable road users. So you have to make your road users safe, particularly the vulnerable users. And then you have to make your vehicles safer, like properly. Is there any, like if you see whether even the back seat people, they have the seat belts or not, and those those bags, which actually you will see that if you purchase some high-end vehicles, so some accident care bags are there, right? So you may not collide directly to the any portion of the car, but with that safety packs and all, right? So if those are present on the vehicle or not, and then how do you do the effective post crash care? So whether uh, while accident when accident occurs, after accident occurs, so what is the time taken by ambulance to reach to the particular destination, what is the facility of that ambulance, and what is the nearest uh, uh, location of a uh, good facility. So is it that the ambulance has the proper first aid facility installed in it? Hmm. Then so those things actually. So these are the topics that had been covered in this module. So now I will wait for some time before I go to the Q&A session. So you tell me whether you have any queries or questions related to the topics, and then actually we move forward to our next part, that is the Q&A. So I will take some rest and I will wait for you people to respond. So We do not have any queries. Shall I move to the Q&A then, or shall I wait for some time? So the first question in the Q&A is accept or reject type question. So nighttime auditing, it is road safety auditing it is referring to. So it's done in detailed design audit. So already I mentioned about the 5-stage procedure starting from the feasibility F stage audit. F stage. Then the preliminary design. Preliminary design stage audit. Next is the detailed design audit, right? And then the during construction reopening, and then the operations and maintenance normal after opening. So nighttime auditing has to be done in detailed design. So you have detailed design, you do not have yet the roads that is building, right? So after you build a road or during you build a road, you have to do a nighttime as well as daytime opening. So it is not at these 3 stages, right? Feasibility, preliminary and detailed design study, you do not have anything like nighttime auditing. So after it has been finished, then we come to the nighttime auditing, right? So it is a false statement. I hope it is clear. So we are moving to the next one. So it is a numerical one. So it is saying that crash history along the road traffic parameters for 5 road sections. So you have 5 road sections, 6-man section length is given, annual average daily traffic is given, number of crashes is given, study period is also given, right? It is not uniform. Whatever data we have, from the data we are getting this. So the correct order of the location is descending order of this crash frequency. So descending order crash frequency means this is priority 1 and then go on priority last, and this is priority first. This is the order, right? We are going through this. Okay. So then what is the correct order of the locations? So also it is given that per kilometer per year you have to calculate. So now it is easy, right? You have number of crashes, you have divided by per kilometer, this is the kilometer length, into the year, here is this. So you calculate it, what would be the answer? While calculating it, you also try to calculate. For first it is 1.49. For the is 2 by 0.5 into 0. 4.4. For C is 30 by 5 into 2.84. 2.84. So D is 16 divided by 3 into 2.96. So 2.96. 14 by 3.7 into 2. 1.6. 1.6. So now so this is how it is done. Number of crashes by year multiply the length, segment length. This is how we calculate. So your first will be B, and then the next one will be D. The sequence would be B, then D, then C, then E, and then A. This is the correct sequence. So B, D, C, E, A. The correct answer will be A. Is it clear to you or not? Is it clear? So it is nothing but the number of crashes divided by per kilometer per year. So kilometer means what is the section length, based on that per kilometer has to be determined, and then per year, right? So this will give you the crash frequencies. Because if you here it is very important that someone gives you that per kilometer per year unit, because suppose I change it to kilometer vehicle kilometer travel, then our AADT will comes into picture, right? AADT and study period, and in that case our answer or result may vary, right? So depending on the purpose, this kind of results may vary. So this is like okay, per kilometer segment per year, this many accidents occurring. But if we say that per million vehicles kilometer or vehicles per vehicles kilometer, uh, uh, what is the frequency? In that case, because the time periods, uh, because the traffics are different, very different, so it might change the results. So if you calculate, I do not think that you will get the same results. Your results are likely to vary. So that is a problem actually. So now the minimum crash rate in MB means million vehicles per kilometer. This is million vehicles kilometer travel. This is the unit. Okay. So the minimum crash rate. So crash rate, if you remember, it can be per kilometer, it can be per a number of vehicles, means the vehicle population, it can be the vehicle kilometer travel. So here it is vehicle kilometer travel or per million vehicle kilometer travel. So now so this is actually given, this should not have been given, this is the calculation, but still we will calculate, right? Because we are anyhow doing it, so we will calculate, but this should not be given, this should have been given. So now our number of crashes are, suppose for location E, our number of crashes are 9, right? Million vehicles kilometer. So our vehicles are 2900 ADT, number of vehicles, into 365 is the per year, into 2.75 is the year. So then this many number of vehicles we got through the total entire period, right? So per kilometer means we have to also multiply with 2.2, right? And per million vehicles it is saying. So here also you can divide it by 10 to the power 6. So this many number of vehicles by 10 to the power divided 6, that is the per million vehicles. So you can say 9 into 10 to the power 6 by this. So let me calculate what is the number that will be coming. 2900 into 365 into 2.75 into 2.2, 9 into 10 to the power 6. Okay, wait, let me do it one by one because it's a normal calculator, so it may not be able to calculate that much. Divided by 6 point, so 9 by 6.403 by 6.403 is coming out to 1.405. Right, so the minimum crash rate. Similarly, can you calculate for the other B, C, D, E, so that at least we can see that whether this is matching with this octane crash rates. For first it is matching 1.41, we also got 1.405. So if we can round off, we are getting the 1.4. That is okay. But for other, what about the others? Can you calculate? I will wait here for some time and calculate. And you tell me that whether you are also getting the same results or not. So maybe I will also do this one, which is the least one. So the number of crashes are 23 divided by 6300 vehicles into yearly 365 into 1.5 into 5.5 should give us the crash rate. What is the number? 6300 2365 into 1.5 into 5 per kilometers. 1, 2, 3, 4, 5, 6. So 18.62595, 18.63 if we consider 23 by 18.63. 1.234. 1.234. So it is 1.234. So the answer would be this C. This is the minimum crash. I hope you will be able to calculate other for other locations as well, right? And you will get the same results. So results are given, just you have to calculate, right? Because MD is given, so per million. So you have to divide it the number of vehicles by 10 to the power 6. That is the million. So the next question is match the items given in column X with its corresponding items given in column Y. So column X, the first statement is graduated driver licensing systems. So do you know that what do you mean by graduated driver licensing systems? So here it is meaning that suppose right now the rule of taking any or getting any license, that first we go registered, applied, and we are getting what you called that's a pre-license kind of thing. We got pre-license, and then within a time period we have to give the exam, the vehicle exam as well as the road sign information exam, and then if we pass it we are getting the license. Okay. So now the problem with this is, suppose we are new and we just know how to operate vehicles and we have a fairly good idea about the road traffic signs, so we are getting the license, but we are not efficient enough to drive the vehicles on maybe expressways or the national highways or whatever, right? And that may also lead to accidents. So to get rid of this, so there is a solution which is called the graduated driver licensing systems. So where you will get a license, it is also kind of pre-license based on your initial exams and all, and then as the time passes by and you are gaining more and more experience, and initially you are not allowed to ride on suppose expressways and other roads, and as time passes by these restrictions are one by one lifted, and then gradually you will get a license after some couple of years, right? So that is called the graduated driving license systems. So it is proposed so that the accidents due to incapable drivers, right? So that can be reduced up to a certain extent. And the next statement is maximum speed of commercial vehicles at per speed governance. So what is the maximum speed? Then the maximum speed limit in urban areas as per MOR, and then the behavioral interventions. So graduated driver licensing system is an effective intervention, of course, any day. Behavioral interventions, you can say it's a not very effective interventions, because if you consider only the behavior, you may not able to capture the, means it is not that it is not a effective intervention. The problem is that only if you consider the behavior, it may not be an effective solution. So the statement could be only behavioral interventions may not actually lead to better better outcomes in terms of road safety. So here maximum speed limit in urban areas is 70 and maximum speed of commercial vehicles is 80. So then your one is B, your two is D, your three is E, and your four is C, B, D, S, C. So this is the correct answer. Right? I think that now we will be able to solve this kind of questions. So which of the following statements are incorrect? Not correct but incorrect. So traffic density does not influence driver's speed choice. So what do you think? So if you remember in the initial modules, we have talked about that how traffic density is and speed is a direct measure, and it has an influence on the driver. That's why in any of the cases we want to use traffic density as measure, right? But due to the difficulty in data collection process about the traffic density, we are using the proxy indicator, that is the traffic flow, right? Because drivers do have a fairly idea about the density of the traffic, not the flow, but the density and the speed. So if there are more denser or congested environment, driver tends to slow down. So it has a fairly idea about the speed of the traffic team as well as the density. So that's why these two parameters are called the fundamental to the drivers. So here it is saying that traffic density does not influence driver's speed choice. It does influence, right? If your road is congested, drivers will reduce its speed. So it's a incorrect statement. It is a incorrect. Next is active intelligent speed adaptation systems. So active intelligent speed adaptation systems are the systems which are inbuilt system inside a vehicle, right? So to and you are saying that they can intervene and correct the speed of the vehicles while overspeeding. Yes, if I overspeeding a vehicles, and if it is there that active intelligent speed adaptation system is installed, so it actually help me to reduce down my speed or give me warning, right? So it's a true statement. It's a correct statement. Correct. Filling of checklist is a compulsory task to be exercised in road safety audit, RSA. So obviously we do have some checklist to fulfill in case of RSA, but it is not a compulsory task. It's a task that you have to do to achieve something else. So it is not like that if you do not have a checklist you cannot do a road safety audit. That is not the point, right? So it's also an incorrect statement. So then detailed design of intersections is checked during the pre-opening stage. No, pre-opening stage road safety audit means after construction, right? Because it is about to open to the traffic. So your construction has been done. So it is after construction. So then detailed design of intersection, how can we check it after our road has been constructed? So it is done on the stage where we check the detailed design, right? So it is also incorrect. So the questions was which of the following statements are incorrect. So it is incorrect 1, it is incorrect 2, and it is incorrect 3. So there are 3 statements which are incorrect, and only the correct statement is the intelligent speed adaptation systems. So do you understand it, or do I need to repeat anything? I hope that you are understanding everything. So the next is select the best batching for the items given in column X with the corresponding items given in column Y, right? So first is the human injury tolerance criteria. So what do you mean by human injury tolerance criteria? So in safe system approach, what happens is that after your vehicle speed is increased to 30 to 60, the kinetic energy which is transferred from vehicle to the person is increased by very much. By a huge extent it increased, and that may lead to death of that person. So there is a human injury tolerance which is there for the humans, and based on that we want to impose the speed limits and other things. So obviously this is directly related to the setting of speed limit. Checking route options or choices. So what are the, so if you want to go to A to B, what are the routes you will choose? This or this or this. So this is usually done in the feasibility stage itself. Whenever we take up a project and we do a feasibility stage study, then only we will doing this. And then the checking of road alignment. So how the alignments are there, is it that this road needs horizontal alignment, vertical alignment, and those things, it is generally done in the preliminary stage. Have to check the road alignment. Then the speed hump. Speed hump means like this, circular, or sometimes it may not be circular, maybe trapezoidal shape, right? This kind of shape. So this kind of speed hump are the effective speed coming countermeasures. So along a highway, sometimes in the minor road, to instead of giving a stop sign, maybe sometimes sometimes people are not adhering to the stop sign. So maybe we are using this speed hump so that militarily the speed of the vehicle goes down and automatically it acts as the yield control intersection. So then the 4 is our C. So BADC. So BADC. So which of the following statements are incorrect? Death rate is expressed as per million population. Actually, death rate is means number of deaths per population, but it is usually 100,000 population, not the per million. It is the 100,000 population. So it is incorrect. A prior identification of hazardous location, prior identification is not necessary to suggest probable countermeasures during a safety audit. This is true. We do not need a prioritized identification of hazardous location. We will go throughout, we will check throughout during this workload safety audit where the problems are. Prior identification, it may not be necessary at all. Then actually you are guiding these road safety auditors. You should not guide anyone. You have some deficiencies, it has to be checked by independent body which is independent of the construction or the construction agency, and they will find out that at which location what are the deficiencies. So safe system approach does not primarily focus on enforcement and education. It is focus on enforcement as well as education. It is not divided. It is a correct statement. Order data models can be used to develop test frequency. No, this is incorrect. So this is incorrect. This is incorrect. So your incorrect is A and incorrect is A. These are the two which are incorrect. So ordered data model means we are talking about the 0 to 1 or in between. What is the rate? What is the severity rate? It is not 1, 2 and 3. It is not a discrete, but it's a continuous like a Gaussian, and it will give me a probability value of the severity. So the next is, which of the following are not true regarding the safe system approach? Human errors are inevitable. So already I told that human errors are inevitable, and in that background only safe system approach has been developed, so that we can get a zero death system, right? We can achieve a zero death system by considering that human are prone to mistakes. Then second one is human can withstand a certain level of, obviously it is called the human injury tolerance criteria. So this is the human injury tolerance criteria. Then fatalities due to road traffic crashes are inevitable. No, this is not true regarding safe system approach. They are saying that fatalities are not inevitable. Road accidents are inevitable. So this is not true. Engineers in charge of road maintenance. Engineers in charge of road maintenance and persons responsible for delayed post-crash care are the only people liable for road traffic fatalities. No, these are not the only people, because traffic fatalities, your driver is responsible. Your who have designed the road, that person is also responsible. So there are many people who are responsible. So this is also not true. Not true. So not true statement is C and D, and the top A and B are true. So do you have anything to ask till that point? So which of the following are correct? Speed does not increase the likelihood of crash, but may reduce the severity level of the. Okay, so imagine your speed is increasing and you are conducting or you are participating in an accident. Obviously, it will increase the likelihood of a crash. So it does not mean it does, but may reduce. It is saying that it is may reduce the severity level. Severity level also increased, not decreased. It is not true. So this is incorrect. Eliminating road safety hazards are the most effective than relocating it. Obviously, if you relocate a road safety hazard, then obviously road accidents will shift to that particular location. So you have to eliminate it altogether. So it's a correct statement. So it is correct. Then traffic calming measures such as raised intersections, gateway treatments are considered highly effective speed management or counter measures. These are highly effective speed management measures because it will reduce the speed near the intersections. Right? Speed cameras do not act as very effective in controlling speed management. Okay, this is a controversial. So speed cameras can monitor it, but it cannot control the speed over speeding. How does it control? But sometimes because we have a speed camera, so people have a tendency to actually control. So it may be a true statement as well. So this is incorrect, this is correct, this is correct. So these three are the correct statements. So this is the last question from my side. Yeah, after this, if you have anything, you can ask, or we will finish this. So the last question is, which of the followings are incorrect or correct? Sorry. So speed does not affect vision of a driver. So if you remember on the uh, first module, initial module, what we said, that as the speed increases, your field of vision narrows. Speed increases. So now if I have 0 km speed, I can see if my speed increases, this vision narrows down. So it affects. So it is not correct. Drivers reduce speed with increase in cognitive burden. So actually what happens, if driver is driving at a greater speed, he has to focus and concentrate a lot, right? So if in case of stress or he is thinking something, then there is a chance that it will reduce its speed. So it's a kind of true step. Engineering speed management treatments include road design aspects. So engineering speed treatment means already you have a road. Now suppose you want to narrow the road, install chicken or install the speed traffic coming measures, or you have to you can cut the trees so that my sight visibility increases, right? So these are called the engineering speed management uh, interventions. Engineering, because for the sight distance, suppose you are cutting the trees, right? Or you are using some kind of chickens or other things to reduce the speed. So these are the engineering speed. But does it include the road design aspect? No, because road design means you can change the width, you can change the altogether the alignment of the horizontal and vertical. So those we are not dealing in detail, right? So that's why it is incorrect. Speed limit transition zones are required when the road function transient. So suppose you have an arterial road, then suppose you are entering to a service road. Obviously, because this, suppose this speed limit is 30 and here speed limit is 70, so you cannot directly reduce the speed. So there should be a speed transition zone which is saying that you are entering the service road, so you should reduce your speed to the 30, right? So this is actually true. So length of transition depends on the, obviously, so whatever the speed of, suppose 72 you want to do a 10, then you have to have a length long enough so that people can reduce time, because there is something called the stopping sight distance, right? So you have to reduce down to the 70 to 10, right? That has to be done. So it is also correct. So this is correct, this is correct, this is not correct, this is correct. So these are the three questions, these are correct. So today I finish my 10 Q&A sessions, as well as I initially discussed the topics. So now uh, it's your time. If you want to ask anything regarding this road safety module I second part, and if not, then we shall close it for today, and next will be the last session for this traffic engineering for this 3 months NPTEL certification course, and we will only be go through the what are the topics that have been done, because already I have uh, developed Q&A sessions for this 12 modules, right? Not modules but the weeks, and I think it contains the 6 or 7 modules. 1, 2, 3, 4, and then 5, 5, and then 6, then 7 modules, I think. No, 9 modules. In total, 9 modules. So then actually we will just briefly look at it, that what are the things that has been covered, and then if you have anything to ask on the next day you can ask, otherwise that will be the last session. So today also I will wait for some 2 minutes, so that if any of you guys have something to ask, you can ask regarding this Q&A also, regarding the numerical as well as the theoretical questions. I do not think that you will face any difficulty in solving these problems. So similar kind of problems you can expect in your final exams. So do you have anything to ask, or shall I close it? Okay, so I take it as yes, that you do not have any further queries to ask. So I will be closing the session for today. So bye, and we will be meeting on the next Friday, means the coming Friday. This is the Tuesday, and this Friday we will meet on 21, 21st, and we will finish the last session for this. So bye. I am closing the session for everyone.